joining in and being part of this Jobinar on AI and IoT in agriculture. On behalf of TCS iON, a strategic unit of Tata Consultancy Services, I, Rahul Soni, welcome you all to this session. We know that the food we eat every day, grains, vegetables, fruits, or essentials, comes from the farms where science, technology, and human effort come together on a massive scale. But today, agriculture is no longer driven only by traditional farming practices. It is increasingly powered by data, intelligence, and precise decision making. Across the agricultural ecosystem, AI and IoT technologies are transforming how crops are monitored, how decisions are taken, and how productivity is improved from soil analysis and weather predictions to detection and automated yield estimation. Computer vision, predictive analytics, and intelligent decision support systems are helping farmers to achieve higher efficiency, sustainability, and profitability. So, in this today's session, which is especially designed for students who want to understand how AI, ML, and IoT are reshaping modern agriculture and farm management, what new skills are in demand across agritech and related domains, how various roles in agriculture, data science, and sustainability are evolving, and lastly, very interesting, real-world use cases demonstration. So we are privileged to have with us a senior industry leader with deep experience in agri-tech innovation and large-scale digital transformation in agriculture. Our speaker brings real-world insights into how AI, domain expertise, and on-ground agricultural challenges come together to create meaningful impact on a scale. I am talking about Mr. Swagatam Bose Choudhury, who is a scientist at TCS Digital Food Initiatives. With over 11 years of industry experience, he has been deeply involved in advancing AI-driven technologies for digital agriculture. His expertise spans computer vision, deep learning, Internet of Things, and embedded systems. His research work focuses on crop stress identification, farm management algorithms, commodity grading, adulterant detection, and UAV-based imaging. He is currently working on cutting-edge innovations in sustainability, digital twins, and advanced sensing techniques for precision agriculture. With more than 23 research publications, over 14 patent filed, and multiple global grants, Mr. Swagatam brings a wealth of knowledge and practical insights to today's session. So let's welcome Swagatam for this webinar today. Welcome, Swagatam. From the introduction alone itself, you can sense the depth, experience, and expertise Swagatam brings to the table. I would like to tell you that this is a very valuable opportunity to engage directly with him and such a distinguished professional. So I encourage you, to make most of it. So without further ado, let's begin the session. So Swagatam, I would like to request you, can you please explain in simple terms what AI, IoT, and sustainability mean in context of agriculture and how these three are connected to each other? Over to you.
Now, when you think of AI is the farm's brain. So AI learns patterns from the data, images from the phones that you're clicking, or the drones, the sensor streams, weather, and the satellite signals. So basically, it detects early and helps to predict the risks that can or appear from the stress conditions and recommends action. So let's say an action can be irrigate now or the delay the spraying of some pesticides. So this looks like a nutrient deficiency or some other conditions. So this basically AI is the farm's brain, which tells you which action you need to do, and IoT is basically the data helps to collect the data and stream it. Now, sustainability is the outcome we care about, like producing more with less water, less fertilizer, less energy, and less waste. So the like healthier soil, lower emissions will be there, and the stronger climate resilience. And how this all connects is like IoT creates a real-time data and control, while AI turns the data into insight, and together they create a precise interventions what you need to do. So think of like a simple closed loops where the sensor detects a condition, AI recommends some action like irrigation and fertigation, and the controller acts like that on the basis of some actuation. So this new data verifies the impact and the model improves. So in short, AI IoT measures, AI decides, and sustainability benefits. I hope that helps.
Yeah, definitely, Swagatam. So, to sum up, I think IoT provides the real-time data. AI converts that data into intelligent decisions, and those decisions help farmers to effectively and sustainability. So,
Correct.
let's move to our second question, Swagatam. So, when we talk about startups or corporates or the government bodies, are they actively working in agriculture, AI, and IoT for the sustainability today?
Yeah, so it's like a broad ecosystem with multiple entry points. So you have agritech companies where they build platform advisory apps, precision spraying services, remote sensing platforms, marketplaces, and other traceability tools, and also agri fintech companies. And then you have corporate and other companies like the seed and input companies, irrigation, or the machinery manufacturers like drone satellite providers. And also there can be part of research and academia where the universities and labs develop or explore new sensors, develop new models on AI, computer visions, and validating them to via field trials. And there can be also government and public agencies like extension systems, where they solve programs on how we can improve or enhance the digital capability of the farmers and how we can basically empower them at different levels. And there can be also NGOs and other ecosystems. So some of the major players in AI IoT enabled sustainable agriculture may include companies like John Deere, CropX, Carbon Robotics, and Plantex, along with Indian players like Crop Infosys. Even Microsoft is also a major player where they're advancing the digital agriculture globally through their FarmBeats platform. So at TCS, we also bring strong domain expertise, hiring agronomy specialists who understand the plant stress, the disease and pest patterns, alongside engineers skilled in AI, IoT, and embedded systems to build field-ready solutions. So in that context, we also have something like a demo farm, which we also like to call as a data farm at TCS Shadri Park in Pune, and that is equipped with multiple sensor nodes, infrastructure, where you showcase the modern agri-tech solutions in real-world conditions for monitoring precise management of resources and also how this all chains up to sustainability. Yeah, hope that helps.
Yeah, thank you, Swagatam, for answering that. And I think what really stand out is how collaborative this entire ecosystem is, and with multiple stakeholders working together to solve real agricultural challenges at scale, right, like
True.
you mentioned.
True.
Going forward, how is sustainability being driven across different industries, and how is the agriculture sector taking lessons from these approaches?
Yeah. Let me answer that pivoting around few slides. The firstly, we'll talk through four impact high areas, how you can enhance the agricultural sustainability with AI and IoT. So we have different systems like we have precision irrigation and fertigation, where the soil moisture, microclimate sensing, and sometimes plant stress signals, based on which basically we see what are the actions that are needed. So AI helps convert the noisy sensor data into some actionable schedule. And the sustainability lens here is that the reduced water waste, reduced nutrient runoff, and better energy efficiency. Second point can be early crop stress detections from so farms lose yield because the stress is detected delayed or at a certain later stage. And if you combine imaging with weather or soil signals, AI can detect early patterns and raise a risk alert quite early before you see the visible signs or the damage actually spreads. So this reduces the pesticides overuse and prevent large crop loss. And thirdly, there can be something on yield forecasting. So where ML models forecast yield and risk, that helps farmers and supply chain plan harvest, labor storage, procurements and logistic, and how both can reduce food waste. Like forecasting also supports credit and insurance decisions. And finally, soil health and climate risk monitoring. So here sensor track moisture, salinity, and microclimate, and AI can recommend signals. So this basically helps you to become more sustainable. And so the idea is measure continuously and based on which you can predict early, and finally you can intervene precisely. So you can go to the next slide. I'll give some more highlights on this. Yeah. So coming to the next slide. So here you can see which industries outside agriculture are seeing the highest sustainability impact from IIoT. and what the lessons in agricultural sector and what's cross domain lessons agriculture can like adopt and make them in this case. So let me share four quick parallels on how agricultural sector can take lessons from the approaches. So one can be the energy sector. So energy sector uses continuous monitoring and based on the demand and response, like balancing loads to avoid waste. Agriculture can adopt the same mindset, like optimize the loads, like irrigation pumps, cold storage, and processing units based on real-time needs, tariffs, and renewable availability. On the manufacturing front, there is predictive maintenance is huge. So sensors and IoT catch failures before the actual breakdown happens. So so similarly for farms or agricultural fields, the equivalent is tractors, pumps, sprayers, and other resources that are used in day-to-day farming scenario. So preventing downtime saves energy and prevents post-harvest losses. Similarly, smart cities has the main function here is interoperability, where unified control platforms and common data models, so devices from different vendors can talk. Similarly, in agriculture, we need the same uh, layer. Otherwise, farms get stuck with siloed sensors and apps that don't integrate. And finally, supply chains, where the real-time traceability improves trust and reduce the wastage. And here, agriculture can also extend this from farm to fork, like monitoring the quality, temperature, and handling events. So issues are caught early. So finally, giving a brief on how what are the different. So we can go to the next slide. Uh, that finally you see how sustainability basically impact across the other industries. So we have seen AI and IoT. So here is simple pattern that you will see repeatedly here. So basically, we sense, we analyze, then you optimize, and then see how you verify the outcome. So here, first, similarly, you can have energy systems optimization, where the grid sensors of the real-time analytics enable dynamic balancing and better renewable integration, like reducing the emissions and improving the resilience. You can have industrial waste reduction for the second point, where the digital twins, like we have twins, which is like a digital replica of what is there on the ground, physical ground, that helps, and anomaly detection can reduce the scrap or the wastage in the industrial or the industries. The equivalent in agriculture is like reducing the input waste like water, fertilizer, pesticides, and minimizing the post-harvest losses. Coming to the third point, like connected logistics. So sensors in vehicles and containers optimize routes and monitor the cold chains. So in agriculture also, the cold chain visibility directly reduces the food spoilage, which is like a major sustainability and profitability lever. And fourthly, in like a something like a smart city infrastructure, we can have distributed sensing monitors, air quality, traffic, and water usage. So for agriculture, distributed sensing efforts across fields and villages supports shared resources like irrigation canals, community water, and how digital pest surveillance can help to give a coherent and connected ecosystem. I hope that helps to give an idea
Yeah,
on.
definitely, Swagatam. Thank you for clearly explaining that. I think different industries have already proven that when you combine real-time data, intelligent
Hmm.
prediction, and coordination across the chain, you cut
Right.
waste and raise resilience. Agriculture is clearly adapting these playbooks and in smart and context-specific ways. So that's really interesting to see. Uh, let's move to the opportunity sector right now. We have already covered the basics part. So
Mhm.
want to ask you, Swagatam, since you have already what entry-level roles these companies typically hire for, and
Hmm.
what are abilities freshers should start building to be ready for these roles?
Right. Yeah. I'll pivot this around the slide where there are basic three major skills, that you can start learning to upskill or to try building something on AI and IoT systems. So the first is IoT and embedded systems. So this is like at the foundation layer because agriculture starts with sensing the real world data, the physical environment literally from the ground level. So if you want continuous visibility into field conditions, we need reliable sensors, microcontrollers, connectivity, power optimization, and a scalable device designed for deployment in harsh environments. So these skills are used to build the actual sensor nodes and edge devices that collect the field data and make it available for monitoring and decision making. So that is why roles like IoT engineer, embedded or engineer at the edge side and farmer developer are so important, coming to the physical level or doing things from the start. Second area is computer vision and image processing. So in agriculture, many important signals are visible, like pest signals, patterns from diseases, or nutrient stress, weeds, and other crop patterns. So skills in data cleaning, pre-processing, and then basically annotating the data, then developing algorithms on how to identify in real world scenario, building models around it, and deployments are vital. So these skills are used to convert the images from different sources. It can be phones, drones, it can be field cameras into insights for detection, for a detection-based system that can identify visible crop issues in a reliable and scalable way. So that leads roles such as computer vision engineer, image processing engineer, and someone who can be skilled in deep learning based techniques. The third area is machine learning, where once the data is available from weather sensors and farm operations, the next step is how we can predict what is going to happen in the next layer. So this is where time series and multimodal data modeling becomes important. So these skills are needed to predict, let's say, pest and disease risk, like at what time or what window this specific pest may happen if these conditions of the ambient are getting triggered, and other farm indicators before the problem becomes too severe to control. So, in practice, these models help generate forecasts and recommendations that support timely decisions in the field. So, this is where roles like ML engineer, data scientist, and predictive analytics engineer come in. So, a simple way to understand this is that IoT captures the data, computer vision helps to detect the visible patterns, and machine learning predicts why and what can happen next. So while we are discussing agriculture here, these are not like agriculture only skills. They're like the core digital engineering capabilities that can be applied across multiple industries and domains. So one more important point is the skill. Once the skills are learned, they're highly transferable. That you've just mentioned. So the value of these skills is not only in one sector; it's learning how to build an end-to-end, intelligent systems that can work across industries. I hope that helps.
Yeah, I think with your explanation, we can think of the versatility of this domain actually, AI in agriculture and IoT.
True.
Swagatam. So thank you for explaining clearly about that. So what are the certain highly prevalent use cases in this industry and where AI and IoT can be seen playing a major role? So can you please explain with few examples?
Yeah. Yeah, right. So coming to the real world use cases, why? So basically, why we move from why to how, and what are the different sectors that it can impact. So in the next few slides, we'll go through examples of IoT and patterns in agriculture, starting from the ground level sensor fusions like farm monitoring through multimodal sensing, which is the point one that is on the top left. And then we have something on the drones, how we can basically uh, use drones to cover large plantations and monitor them with drone based imaging. That is for the three. And after that, you can see how quality assurance, once the you have a harvest and cultivated what you need, how we can basically see how imaging for quality evolution or detection of adulterants or different foreign objects can be determined. And also how, other than agriculture, how the AI and IoT can play a different role and impactful role in livestock and fisheries, and also using image analytics. So I'll touch base upon each of these topics in the upcoming slides. So coming to the first use case, that is farm monitoring through multimodal sensing. So on the left hand side, you'll see a dashboard image which basically shows some area which is basically geotagged, and then some layers of data that is coming from there, and some tabular data also. So, let's begin with the ground level, literally. So, if you want to understand the crop health properly, we cannot depend on just one specific signal or one specific type of data. So farm is like a dynamic biological system where what we can see on the leaf is only one part of the story. So real picture of the whole picture emerges when we combine the crop, what the crop looks like, what the weather is doing, and what the field sensors are capturing, and how those conditions are evolving over time, and how they're basically related. So that is the idea behind multimodal sensing. So think of it as giving the farm multiple senses. IoT sensors tells us on the top left image, bottom left, you can see different sensors and different what are the different multimodal sensing techniques can be used to get the data from the accurate layer. So IoT sensor tells us what is happening in the field and the surrounding environment, like in terms of temperature, humidity, rainfall, soil condition, and other parameters. Imaging tells us what is visible in the crop, like the stress or disease symptoms, pest damage, or any nutrient deficiency that you can visually see, and weather and satellite context at the broader environmental view. Now, when the signals are combined, AI can begin to detect patterns much earlier than a person would notice during their regular routine scouting or schedule. So, the major use cases that can come for this is one can be a disease and pest prediction. So, if certain microclimate conditions are developing, so the system can basically identify the risk in advance, let's say in a window of 7 to 14 days. So that early warning is extremely valuable because the farmer gets time to react. Like they react before even the damage spreads. So then comes the direct disease and pest detection. So using part, so let's say because of some circumstances, the disease actually appears. So the next step is how we can use participatory images from phones or overhead imaging, and using computer vision models to identify what the specific diseases there are, and also let's say pests and even weeds, and stop them from creating any major drop in the yield. Thirdly, similarly, like you have nutrient stress detection, where it becomes more reliable when computer vision is supported by field level sensing. So basically, a leaf may show one symptom visually, but when combined with other soil or ambient context, the recommendation becomes much more precise. Fourthly, insights based on multimodal available inputs like images, weather sensors, and satellite data helps to get a comprehensive view of the crop health status. Similarly, you can have crop yield and related insights that can be estimated based on the sowing information, the soil and the ambient conditions, operations, and other factors that play a role in the farm. From this, there can be multiple business benefits and benefits for the farmers or the users. First is a scalable crop-specific models gives early disease and pest forecast, helping farmers optimize inputs and prevent the crop loss. Second, it can there can be computer vision models helps to detect the stress conditions right at the edge at the locally, enabling timely recommendations and minimizing the damage. Third, we can because we combine multiple signals like images with the sensors and satellite, we provide a complete, reliable picture of crop health rather than isolated readings or siloed approaches. So basically, to summarize this use case, multimodal sensing gives a fuller, earlier, and a more actionable picture of crop health. So let's say, so here we got a view on how multimodal sensing can help. But let's say what happens when the farm is too large, or like how we can inspect effectively from the ground. So that's where the next layer comes in. The next use case emerges, like drone-based monitoring, which gives us speed, coverage, and section level visibility. So you can move to the next slide. Yeah. So this is basically the use case of plantation monitoring with drone-based imaging. So drone surveillance when it comes, so on a plantation or a large farm, one of the biggest problems is coverage, like the large area. So plantations and large farms need coverage at speed. So walking every row or every channel can be a little slow, and by the time one sees the damage may have already spread into multiple clusters. So drone-based imaging gives section level visibility. So based on this, we can detect and abiotic stress conditions. So a drone gives us a much wider field of view in a much shorter time. So instead of depending only on a scattered ground observations, we can scan the entire management zones and identify where attention is actually needed and priority. So now the value here is not only capturing the aerial images using the drones, but how IoT, AI and IoT can have the intelligence to convert those images into actionable zone level insights. So the use case for this can be looking at a few use cases, like on the left hand top side you can see multiple images, like so on one of the images you can see multiple hotspots. So this basically gives a view on what the whole area that is and where you need to pinpoint first in order to get the idea where to visit first. And there is some images on how it is color coded based on red, yellow or green, so you can understand the severity level in which it's progressing. And also if you go there and see some images, you need a deeper insight on it, you can use your mobile camera to see what is the actual the infestation there is, that is on the image with red bounding box telling one of the conditions. So the uses can be abiotic stress detection. So plantation may show nutrient related or water related stress in specific sections. So drone imaging helps identify those patterns spatially. So interventions can be localized instead of a blanket application. Similarly, we can have identification of biotic stress like pest or disease infestation and assessing its severity with imaging. Then we can see, once you have identified the stress, how you can cluster it to different hotspots. So there can be stress hotspots clusters, which is important operationally. So instead of saying there is a problem somewhere in the plantation, we can say the system can highlight dense incidents areas where spraying or inspection should be prioritized. So the same logic applies for pest and disease forecasting at zone level. So at zone level, the system can predict the stress window before the incident actually happens, which helps the teams to move from late reaction to early prevention. And also like drone surveillance for stress and harvest readiness. So basically, you can use drone images to identify which are the sections it's actually ready for harvest or to cultivate. So in crops like tea or other plantation settings, this helps with the faster scouting and more targeted field action. Similarly, the benefits can be multi-pronged. So from an operational perspective, the benefits are multiple: rapid hotspot detection, like proactive alerts. You can have near real-time monitoring across multiple resolutions and better site-specific. So the largest story here is drone intelligence turns a large plantation from something difficult to inspect into something measurable and manageable. So once again, the sustainability connection is also evident. More precise intervention means better use of fertilizers and pesticides. That gives to less waste and faster response to developing stress. So far we have looked on how multimodal sensing and governing things with drone. We have looked how AI and IoT helps to protect crop health before harvest. But sustainability is not only how things can be or how the crops can be grown well or protected at levels. It also about preserving once it is cultivated or harvested. So that takes us to the next slide, that is on post harvest grading and quality assurance. Yeah. So here you can see different images. So on the left hand side, you can see a different tea that is cultivated and what are the different, how you can basically use different type of images or sensor data to analyze what is cultivated and how is it good, and what is the quality of the harvest that you have cultivated. So large fraction of the food loss happens after actually it's been harvested. So during like a sorting, transport, storage, and processing, there's a large wastage that happens. So uh, so so here in many agricultural systems, one of the biggest hidden losses happens after the crop is already produced. So a farmer can do many things right during the season, like good seed, careful irrigation, timely crop protection. But if you cannot reduce the post-harvest loss, we are not just protecting profit, we are also protecting all the water, fertilizer, and all the resources that actually went while growing the crop. So there can be multiple use cases how we can use AI and IoT to have a quality control on the produce that we have harvested. So one can be post harvest grading. So you can use imaging and AI. So you can evaluate the produce quickly and consistently against quality standards. That means you can have faster grading, fewer disputes, and better decisions right at the farm gate at the entry level. Second, we can have residue analysis. So rapid screening methods can help identify whether the produce may carry pesticides above a certain threshold or acceptable levels, or that is the produce is okay to go to the next level. So that adds an important dimension of safety and compliance that is vital for human health. Third can be ambient condition monitoring in transit and processing. So with IoT sensors, we can continuously track the temperature, moisture, and other crop-specific conditions. So if there's a deviation, we don't need to wait for the until the spoilage becomes visible. The system can alert us early based on the parameters that you are monitoring. Fourth, we can have crop quality monitoring in warehouse and silos. Instead of relying only on periodic manual inspection, we can use sensors and computer vision for non-invasive monitoring. So this system can detect conditions linked to spoilage, damage, or environmental breaches before they actual have become major losses in the industry. And finally, let's say we have already passed all through this and we find some foreign matter or some adulterant that you don't actually need or that actually degrades the grade of the harvest. So using spectral imaging, so which is something more than RGB imaging that you capture from a mobile. So using spectral imaging or machine vision, it becomes possible to detect the contaminants or unwanted material that may not be easy to catch with a naked eye. So the largest story here is we are moving from a reactive quality control to like a proactive quality assurance. So instead of discovering a problem at a later stage when the damage is already done, AI and IoT helps us to detect the risk early, maintain the standards continuously, and also intervene before the actual value is lost. Similarly, here the benefits can be multiple. From a business perspective, this improves the quality at the farm gate, reduces the contamination risk, and protects the produce during the transport, and also lower storage losses. From a sustainability perspective, it reduces the waste, improves the food safety, and makes the supply chain more reliable. So it's not enough to grow well. You also need to see how you can preserve well with the digital technologies in hand. So now here, the previous slides were about protecting the value of the crop from harvest, and this one, the next slide, will show similar AI-driven thinking can be applied not only to agriculture but also, let's say, livestock beyond crops. So we'll see how livestock and fisheries can help. So coming to the last segment of the use case. So AI and IoT is not just relevant for not just relevant for agriculture. It is also relevant for livestock, fisheries, as it is for the crops. Because here too, the core challenge is the same. How do you observe better, understand earlier, and act more precisely? The slide focuses on the image analytics that can be done based on the data that can be harnessed from the livestock. So here you can see different images where you can see cow, you can see fish, and you can see prawns, and what are the diseases and what are the different uh, things that you can identify from an image or a video, or let's say IoT signals. So the first use case is species identification. So if the system can correctly identify the animal species, it creates the foundation for the more targeted downstream recommendation that can help to fuel the system or the pipeline. So second is like breed identification. So within the same species, breeds can differ significantly in behavior, productivity, feeding requirements, and resilience. So based on the breed, there are different things that the farmer or the livestock owner needs to do. So accurate breed recognition can support much more than precise management. Then there can be a physical characteristic detection. So imaging or like the data from images can help assess visible traits such as the size, the stage, the color, or the other morphological features that matter for the farm management decisions. Then one of the most practical applications is the body condition score that is called a PCS for livestock. So this essentially can be equivalent like something we do for similarly for humans. So this helps to understand how this can be a strong indicator of animal health and the nutritional status. So if we assess it consistently with imaging and other signals, we can identify if the animals are need attention much more earlier, or like is there something wrong with the livestock that you have. So this basically gives an idea. So and beyond still images, there is behavior identification by combining audio, video, and other sensor-based inputs. So it becomes possible to monitor cattle behavior and detect patterns that may indicate stress, illness, or any, let's say, productivity or the reproductive changes for the cow, or let's say the livestock in hand. So traditionally, a lot of livestock management depends on manual observations or based on the experience the livestock owner has. But those remain important, and those are the domain knowledge that you need. But AI can strengthen that process by adding consistency, frequency, and at scale. And similarly, here also the benefits can be multiple. There we can have better recommendations based on the species and breed. Can have better management planning from physical traits, and you can have earlier health interventions, so the body conditions coding, and also improved herd productivity and animal well-being through the behavior insights. So, and from a sustainability lens, if you see, healthier animals mean better feed efficiency and better resource use. And that basically gives improved welfare outcomes. So across crops, post-harvest systems, and livestock, the message remains mostly uniform. So AI and IoT help agriculture move from one occasional observation to continuous intelligence across the whole pipeline and the ecosystem. And that is the really thread connecting all these use cases, from field sensing to drones to storage to livestock. And the more measurable the system becomes, the more precise, sustainable, and scalable our decisions can be, and help to give more informed decisions. Yeah, I think that concludes the four use cases we have touched upon. So this slide basically gives a view of all the publications that you have done. So it's not that we have just identified use cases and then solved that at pilot layer. So we have also published our research and whatever we have done along the publications that we have done. So agricultural AI is not about accuracy on a data set or on paper. So it's about how robust your system can be, and it can uh, you can basically use it on vast domains. So this is basically a list of the publications that you have done on the findings. Yeah, I think that ends the use case and the theme around it.
Yeah, so I'll just ask you a few questions. The first question that I have is agriculture stable and a safe career choice for future?
Yeah, absolutely. If yeah, just give me a second. Yeah, so if you see across multiple domains, right? So agriculture not only helps to give insights on the domain knowledge that you have, it helps to also bring out the what more you can do with the domain knowledge, and also help the digital side of things. Let's say you know what are the patterns or the symptoms based on your studies on agriculture or different domain knowledge that you have gathered, how this can be translated to something on a digital phase. So you can basically help to annotate data, sanitize the data set, help what are the fine tunings needed in the AI or the models that you have. And this knowledge doesn't comes with someone that you're doing IoT or core skills. This comes with someone on the agricultural domain. So you similarly you also have different people in our team also from the domain team, who basically help us to give the in-depth knowledge that is actually the creates a differentiator between the models that we have online or you can download, and the models that you try to deliver and produce, or the algorithm that you do. I think that I hope that helps.
Yes, it certainly does. Thank you so much, Swagatam. The next question that we have is what is TCS doing for agriculture?
So there are different programs in TCS in the research side and also in the other domains, where we need like entomologist or agronomist to help us give a better in-depth understanding of the domain knowledge. So so basically there are two things a client needs. One is, let's say you have something like you have a very long field or a large farm, and you need to basically see how you can manage it better, like reducing the pest and disease infestation and boosting up the yield. So here one major ask is, from the ground level, what are the domain knowledge you can have. So here you need domain knowledge experts in order to understand the patterns, let's say visible patterns, what are the data points there, and what are the different anomalies that can be there on the plants or the crop, where the user is interested basically. So that gives a domain knowledge to the scientist or the AI engineers on how to build the models in a better way, or how to fine tune the algorithm so it basically gets contextualized to the crop that we have. So that's where the agriculture knowledge is like a major differentiator, and that plays an important role. Yeah, I hope that helped.
Yeah, absolutely, Gautam. Well, can you please confirm? So, audience, to help you build right skills in the right way, TCS IN has partnered in FinTech by IIT Guwahati, Cybersecurity by IIT Roper, and VLSI Chip Design by IIT Hyderabad. Each of these programs is built for learners like you, students and early professionals who want to build a strong foundation and stand out in the job market. You will learn real skills, get expert mentorship, and earn co-branded certificates from IITs and TCS. So as you can see on the screen, the details has already been on here. More on the micro site and start your learning journey. So to explain the key focus areas of these certifications, these practical industry projects and problem-solving approaches that industry actually uses. Another major highlight is that these are live sessions conducted by faculty from IITs and premier institutes, giving students a rare opportunity to learn directly from experts. Earning these certificates adds strong value to students' resume. An IIT branded certification immediately stands out during interviews and signals credibility and seriousness, industry readiness to recruiters. Hence, I would encourage all of you to enroll in these programs, which will help you to build confidence, develop practical skills, and become truly ready for the maybe for 45 seconds or 50 seconds. So as an expert, what you feel, Swagatam, how these programs will help students to groom their career, to start their learning journey, and how these programs will help to groom themselves? Please, your views.
Think all the three certificates that you mentioned, right, are relevant to AI and IoT in agriculture and also in a larger domain, because like they're the core complementary foundation skills. So like one is the AI in fintech that you have mentioned, right? So this basically helps strengthen the applied AI ML thinking and the model development and deployment that the students can learn. And cybersecurity essentials is like helps secure the connected sensors, devices, and the data. So once the data is there and you have the models, how you can basically make it secure, so other intruders can use it. And finally, VLSI chip design. So this basically builds the hardware and the edge computing skills that are based for the core IoT system. So I think all the skills and the certifications that I've mentioned are very beneficial and would be very impactful in learnings for AI and IoT.
Thank you for sharing that, Swagatam.
So basically, I'll answer this in two complementary tracks. So one you can see on the track one, that is on agriculture, life sciences, that is the domain level expertise that you need, and track two is like the core IoT, EC or the CS students. So the for someone who has studied in agricultural based domain, so the superpower is agronomy context. So you basically you get the chance to define what to detect at by the machines or the crop stage, the stress symptoms or the pest and disease signatures, the nutrient deficiency patterns, so that the AI targets the real outcomes. So you have heard something like a HIL, that is the human in the loop concept. So all the AI systems that are there in the ground or being developed have to need some level of human expertise at some other point. So that is where human in the loop comes in. So it helps to validate the ground truth, validate the observations, and sanitize the noisy data, and helps to annotate and demarcate the images before they can actually go into the models or in the pipelines. So creating strong data capture protocols like record context like the location, the plot, the variety stage, with the management zones. So this reduces the bias and improves the generalization of the models or the algorithms that you have. Coming to the track two, that is on core IIT or EC or the CS students. So here the idea is to build the algorithms or the models based on the data that is purified or cleaned from the domain experts or the people from the agriculture from the track one. So it helps for the detection and severity scoring using the analytical ground truth data, build AIML time series prediction models based for the risk forecast using weather and IoT signals, and produce explainable advisories. Also design IoT devices like sensor nodes, power optimization, or how you can reliably manufacture devices or produce devices in harsh conditions. So basically every piece of the pipeline is important at some or the other stage. So let's say if you want to have project ideas near it, so you can have like a small soil moisture based smart irrigation. So one simple and practical idea can be is to build a smart irrigation system using only, let's say, like a soil moisture sensor data. So here the agricultural students can help define the moisture thresholds for the specific crop that you want to target, while the technical or the core IIT students can help build the sensor unit, collect readings, and generate the irrigation alerts, the recommendation based on the algorithm or the models they can develop. And the another project idea can be like something like a phone-based crop disease severity detection. So here another impactful project is like a phone-based crop disease severity scoring and detection. So agriculture students can help define the symptoms or the patterns or the major levels of severity based on the crop and the images that you gathered, while the IT students can train the model and deploy it as a mobile or a edge application. I hope that helps to give a view on how different disciplines can combine together to build a intelligent finance system.
Yeah, definitely, Swagatam. Thank you for giving this clarity. Yeah. Rohit is asking, I come from a computer science background, but don't know much about agriculture. Can students like us still enter this field?
Yeah, sure. You can obviously enter the field and you can do a well-depth study on what are so basically first you need to scope out what are the requirements or what is the project that you're working on. Based on that, you need to understand what are the domain knowledge that you will be needing. So where the agricultural or domain experts come, but also you can give a view on what are the different things that you need to learn based on the domain knowledge, and then you can start using your expertise or skills in IIT or CS to start developing the models. So once you have the domain knowledge, you can use it to fine tune the algorithms or develop the algorithms from scratch.
Nandana is asking, good evening, sir. I am Nandana. I am botany and graduate student from Kerala. My question is, how can IoT devices help reduce water and fertilizer wastage in agriculture?
Yeah. So botany, I mean, again, botany, you have the domain expertise. So basically, let's say for irrigation and for fertilizer use, right? So basically, once you identify the nutrient and the stress condition based on the imaging, right? Based on the computer vision models, you need to basically, you can also identify the severity. So let's say you have, uh, to simplify it, you have two plants in your garden. Now you identify from your phone based monitoring system that one of them is having deficiency in, let's say, nitrogen, and while the other one is growing up well based on the images that you have collected and analyzed. So based on that, you can optimize your resources on which plant you need to monitor more or need to take care and prioritize that. Similarly, if you have something like a soil moisture sensor, you can basically see what is the exact need of the soil, and then irrigate accordingly instead of doing a blanket spray or like a scheduled spray. So that would help you to optimize the resources at each and every level.
Right. Okay, let's take the last question. Rutuja is asking how to help farmer to give the correct information regarding plants and seeds, how this technology will help. And is it restricted to only fruit farms or it covers all?
Yeah, so it's not restricted. So coming to the first part of the question, like how to help farmers regarding seeds and other domain knowledge, right? In order to help them choose the right seeds, right? So first thing you need to basically identify what is the area that are trying to sow, right? Let's say you specify an area, you identify what are the climatic conditions there are, and then you basically see based on digital technologies what is the soil health, like what is the soil terrain, what is the soil health. Based on the soil health and the region you are there, you can basically identify different seeds that are well built for specific, let's say kharif or the rabi region, rabi season, right? Based on the seasonal crops that you're so basically if you idea is, let's say based on the climatic zones or the climate, you cannot have something like a start growing mango on winter, right? Or start growing something different on a different season. So based on the ambient conditions and do a granular based digital survey, you can basically identify which seeds to grow. No, it doesn't restrict to any certain fruit-based farm. I mean, you can use it for other farms also. Let's say you have orchards or you have perennial crops like tea or coffee or different plantation crops, which we have seen like how you can use drone to monitor. So ideally, you can have any number of multiple domain, multiple crops, multiple seasons, and this is not restricted to only food based. This can be used for multiple, multiple crops, seasons, and cycles.
Yeah, thank you, Swagatam, for that. And I think students might have noted down the points which you have mentioned in today's webinar. To Swagatam for sharing his valuable insights on how AI and ML are transforming the agricultural landscape. And I think his perspective gave us clear understanding of the exciting innovations happening across the agri-tech ecosystem and the farms to supply chains. So thank you, Swagatam, once again for coming today in this webinar. And dear audience, we
Yeah.
hope today's webinar offered you with fresh ideas, clarity, and inspiration to explore the growing opportunities in this space. And I hope you will make maximum of the opportunities like Swagatam mentioned in this webinar. And I explained about the 3 courses. It's very easy. Click on the links which we have given to you. You can explore, you can write to us as well on our email ID. So lastly, a very warm thank you to each one of you for your enthusiasm, thoughtful questions, and active participation. Your involvement is what makes sessions like this meaningful and impactful. With that, we conclude today's session. Thank you once again, all of you. Take care. Goodbye.